Let's see the first thing, which is the most common thing for Ramanujan. Whenever you hear about the word Srinivasa Ramanujan, this is what comes into your mind: the Hardy-Ramanujan number. So when there's a long story. Okay, you can read it on internet. I don't want to review that story. But Ramanujan came up with the concept that, and that too, it was instantaneous. He didn't work on it. It struck his mind, at that very time when he saw a taxi number 1729, a taxi number. And somebody said, his friend, he said, the number seems to be very boring. But he said, no, it's a very interesting number actually, because that number 1729 is the smallest number which can be expressed as a sum of cubes of two natural numbers in two different ways. So 1 cube is 1 and 12 cube is 1728, 9 cube is 729 and 10 cube is 1000. Both of these gives 1729. There's no number below 1729 which follows this property. And after that, there was a string of numbers, which started flowing in. But 1729 happens to be the smallest number. And that was put forth by the great Srinivasa Ramanujan. After that, if you want to know something more about this Hardy-Ramanujan number, I must tell you that 1729 is, expressed as a product of primes. So I've written it there: 7 times 13 times 19. If you take the product, you will get 1729. There are very few numbers which can be expressed as product of primes. It's very difficult to actually make factors of 1729, because the students know the divisibility rules of 2, 3, 4, 5, 6, 8, 9, 10, 11. They don't know the divisibility rule of 7. How do you check whether a number is divisible by 7 or not? Especially when it is a like 5-digit or a 7-digit number. And that's where the problem is. 1729 has no other factor below 10 other than 7. And above 10, 13, 19. If it is difficult to identify whether a number is divisible by 7 or not, then it's all the more difficult to identify divisibility by 13 or divisibility by 19. And that's what is the beauty of the brains he had, the ace Srinivasa Ramanujan. So he told us that it is, it is a product of three prime numbers, 7, 13 and 19. And after that, a lot of researchers went into it, and the largest known number which follows the property that it can be expressed as a sum of cubes of numbers in two different ways is 885623890831. And how can it be expressed as a product of primes? Look at the prime numbers here. They are all 4-digit, 5-digit prime numbers. Now we have supercomputers, we have smart machines which work for us, and but we created those machines, right? And there was initially, when he worked, Srinivasa Ramanujan worked, there were no huge machines to assist us. It was all his own creation, his own thinking. And that's the beauty of the contribution made by him in such a small age. Look at the prime numbers there. They're huge prime numbers, right? If somebody asks us to list down factors of a 5-digit number, it's going to be difficult. Okay, so let's see another thing. Now, this is a Hardy-Ramanujan number, right? 1729. The date of birth of Ramanujan, 22 December 1887. That's the date of birth. We celebrate that as National Mathematics Day, right? And the sequence in which the digits appear in his date of birth: 22121887. We can have an operation in which we will have all these digits in the same order: 22121887. So I'll show you here. Look at this: 22121887. Now I put some operations in between all those digits. You can check minus, plus, into, divide, all those things, right? And some brackets also. Just try and calculate the expression. Just simplify that expression. You will be surprised that you get the same number again. And what is that number? The Hardy-Ramanujan number, 1729, from his date of birth. And that's not all. The death anniversary of the great Srinivasa Ramanujan happens to fall on 26th April 1920. Now, what are the digits there? The digits there are 260411920. Now, you can actually have an expression in which all those digits come in the same order which I was talking about, and still you will get the same Hardy-Ramanujan number 1729. So you can calculate this and check whether you are getting a 1729 or not. I'm sure you are going to feel happy about it. And that's the beauty of, mathematics. It's everywhere, It's only that you should be able to identify mathematics around you, and you start appreciating mathematics. So that was about 1729. Ramanujan was like an ace. He heard that students are doing those magic squares, right? Where the row totals and the column totals and the diagonal totals are exactly the same. And they were following like one or two magic squares which came from other countries. So he started working on the magic squares also. And believe it or not, he made a magic square out of his date of birth. Yes, out of his date of birth. And watch the entire video, friends. You are going to make a magic square out of your date of birth after watching this. Everybody will be a magician, a mathematician. Students, watch this. This is what he propounded. He said, okay, 22nd December 1887. So 22nd, that 22 forms the first number in the 4 by 4 matrix here. December is the month number, that is 12. 18 is the century and 87 is the year. 22nd, 12, that is December 1887. So you have 4 numbers there. You can also write your date of birth like this in a 4 by 4 grid. And now Ramanujan wrote some numbers there. I'll relate the numbers and then I'll tell you the rule how you can do it. So can you see this 22 is related to some of the numbers like 25, 23, 24? It's related to that, right? So you can see we are increasing or decreasing 22 by some quantity, like add 1 you get 23, add 2 you get 24, add 3 you get 25. Getting it? And then there are some numbers which are very closely related to 12, just like this 9, 10, 11. They are very closely related to 12. And some numbers which are very closely related to 18, like this number 17, then we have this number 19, and then this number 16. And the remaining numbers are all close to 87. See, 88, 89, 86. Now, the most surprising thing here is the rows. All the rows will add up to 139. All the columns will add up to 139. All the diagonals are going to add up to 139. But he thought beyond that. And now you are going to watch the magic. So if you have a 4 by 4 grid like this, I'll draw a rough grid here so that I can just explain it to you. What other properties does this magic square have? So if you have a magic square like this, check these 4. You are going to find that the sum is again 139. Check these 4. Again 139. Check these 4. Again 139. And check these 4. Again 139. 4 more patterns there. And you have so many other patterns. I'll tell you, these magic squares This is not a traditional magic square. It is something special. It's the output of a brilliant and a genius brain. Check these two and these two. That means these four. 139 again. Check these two and these two. 139 again. Check the corners. 139 again. And these type of patterns in the magic square in which Ramanujan brought up from his date of birth continues on and on. Maths is amazing, friends, amazing. And you'll be surprised to find how the total comes out to be 139 every time from Ramanujan's date of birth. You can try using your own date of birth. Even if you get some negative numbers in the grid, doesn't matter. Your total for all these patterns which I'm telling you is going to be the same. So I'll just give you a overview of how you have to make this, and then you can take the screenshot, try that, and display it on your everywhere on your social media, right? And display that in front of your friends. You will feel like a superman. Okay. Okay, so you can make your own magic square from your DOB, that is date of birth. Now this is date of birth. Suppose I take my own date of birth. This is DD, that means 2-digit date. It can be a single digit date also. Then MM, this is the month number. This is the century. Most of you, the students there, school students, will be having a 20 here, because 20, if you are less than 22 years of age, then it is 20 something. Okay. Then the year. So year can be a single digit number or a double digit number depending on in which year you were born. So take DD, MM, CC, YY like that, and now write all other numbers in the manner which I have shown there. So you can see this is the entry here is year plus 1, year minus 1, year plus 2, century minus 1, month minus 3, date plus 3, century minus 2, date plus 2, month minus 2, century plus 1, date plus 1, and month minus 1. Try this, friends. Take your date of birth, try this. Let me know in the comments below whether your answer is correct or not. And let's salute the man himself, Srinivasa Ramanujan, for giving us all these precious things. I tell you, this video is a very compact video in which I have taken up only Hardy-Ramanujan number and the concept of magic square from date of birth. But his contributions are infinite. And if you start studying Srinivasa Ramanujan, you're going to be more appreciative of his contributions towards the field of mathematics. Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. So what do we have in this video? A very special video for all maths lovers. We all know Srinivasa Ramanujan, an ace mathematician who contributed so much in so little time. You can see the period for which he lived, 1887 to 1920. How much period is that? 33 years. In that period of time, most of us, are gearing up for life. We are just waking up to face the challenges of life.